This is for integrated 2, 8.2.2, and I'm going to talk about how to calculate the area of a regular polygon. Now, if it is not regular, we would have to dissect it and approach it in a completely different fashion. But if it is regular, then we get to use the following steps. And I'm going to show you a couple of different ways to do this. I'll show you 2 different ways, and then you can ultimately determine the way that you want to solve it. So the first one is the directions that we have written out here. We're going to draw an isosceles triangle. All right, so that's what we have here down in this bottom shape. So I'm going to run the directions and run this example at the same time. So I'm going to go ahead and highlight in green. So this is going to be our isosceles triangle. I know it's isosceles because if A is the center, which it is, then the radius is from the center to a vertex. So I know this distance and this distance are going to be the exact same thing. So there's my isosceles green triangle with vertices on the regular polygon. Okay, we want to determine the area of the isosceles triangle. All right, so that's what I'm going to do. I'm just going to go ahead and pull that triangle out. And I'm going to see if I can calculate what the area is of it. So the information that I know, and then let's go ahead and draw in the red portion as well, which is called the apothem. So there's the red portion. Let's get rid of the extra part here down at the bottom. And we know that this is going to be perpendicular to the side. I also know, looking back at the picture, that I have this length that was given to me over here of 12 units. So I just highlighted that in green. So that means that every single side length on the outside of the triangle, on the outside of the polygon, is going to be 12 units. So all the way across is 12. All right, so here's what I know. If that's 12, then I can chop that in half. This becomes 6, and this becomes 6. All right, now I need to be able to calculate the area of this. Well, at this point, I don't have enough information to do that, but I can figure out the angles. Now, you decide whether you want to find, so looking at my green triangle here, a couple choices you could do. We could find the blue angle that I just marked up at the top. That would be one of the central angles right around the middle. So taking a look back at the picture, that would be that blue angle, which we know if you add all of those together, you get 360 degrees. That's one thing you could do. Or back to our green triangle, we could find those angles, which back to our picture goes there. Now, to be clear, those angles are half of this whole angle here. So I'll put a little double mark there. So if I can find the big purple angle and cut it in half, then I can find the little purple angle. So let's do the purple angle. Not that it matters. So taking a look at the shape that we have here, we can take a look at how many sides this thing has. So I've got 1, 2, 3, 4, 5, 6, 7, 8. All right. So I want to figure out how big each interior angle is. So each interior, so this goes back to what we did previously. Well, I'm going to find the sum first. And then I'm going to split that sum evenly to each corner. Okay, so from here, we'll grab our calculator and see what we get. So I'm going to do 6 times 180, and then I'm going to divide that answer by 8. That means that this is 135 degrees. That means, back at my picture, I'm going to even put it wherever we want. A big purple angle, double tick mark. That's 135 degrees. So that means that each one of them is 135 degrees. But based off of my picture, I want half of it. So I'm going to take that 135 and I'm going to split it evenly. So if I do that, that's going to give me 67.5 degrees. All right, so back to my picture over here. Inside my triangle, that is 67.5. All right, in order to find the area of a triangle, we're going to have to do half base times height. So I think we're going to need that. So the area of a triangle is half base times height. All right, so we need to find the height here. So back to the green triangle. Well, the height of that triangle, you can call it H if you want to for height. You could even call it A because it is the apothem. All right, using trig, it looks like we can do tangent. So I'm going to do tangent of A. Oh, tangent of 67.5 degrees, my actual angle. Opposite is A, adjacent is 6. All right, let's put a 1 underneath this and cross multiply. So 6 times tangent of 67.5 is equal to A. So A is approximately, now remember, we're going to use this for something else. So make sure that you can use the calculator that I have given you and go up and select this answer. Okay, so what I'm going to do is I'm just going to put a little box around it because I'm going to need that. So that's reminding me that I have to go back and use that key in my calculator, arrow up and select it. All right, so I have the height. All right, now I think I can find the area of the triangle. So the area of, and it is the entire green triangle, is going to be half. Okay, the base of the entire green triangle was 12. The height of the green triangle, well, that was A. So that's me showing that I'm going to go back up and select it. So if I type this in, I am going to get 86.9116, and this is an approximation. That's the area of the green triangle. And I'm going to go ahead and put another box around it because I'm going to use that again. Okay, now find the area of, well, the entire polygon. Well, I think we decided that this was 8-sided, so this is an octagon. Well, if we go back to the actual octagon, I want you to see how many of these green triangles we would actually have. And it looks like it's however many sides we have. So we're going to end up with 8 of these green triangles. So the area of the octagon is going to be 8 times the area of the green triangle, because we have 8 of those. This is going to be an approximation. So remember, we're using this. I'll go ahead and put my box around this. We're using that answer. We're not going to do an approximation of it. We're going to use that, and we're going to times that by 8, which is going to give us 695.2935. Were we given any units on this? Nope. So let's go ahead and just call it units squared. That is the area of the entire octagon. That's one way to do it, is find the area of that triangle. Okay, got a couple more to do. So we're going to calculate the area of a regular octagon. So we're still talking about an 8-sided shape. But this time we have the radius. So I'm not going to draw the whole picture. I'm going to draw the green triangle. The radius would come from the center to the corner. So my 2 green dots. So this represents the center. And this represents a corner or a vertex. The radius is always identified as from the center to the vertex. So I'm just going to go ahead and take that radius of 8, and I'm going to go ahead and put it in this location. So what we want to do is we want to find the area here. Well, in order to do that, I'm going to go ahead and take that red height, draw it right in again. Get rid of the extra. this is perpendicular. Okay, now I'm going to approach this a different way. Instead of finding the angle down in the corner, I could actually find the angle up at the top instead. So I'm going to go ahead and find that angle. Well, if you think about this, in the previous shape, it was an octagon. We had 8 of those triangles. Well, the center of the octagon is going to be equal to 360 degrees. So I'm going to take 360 degrees and I'm going to split it evenly to each of the 8 green triangles. So if I take 360 divided by 8, that's going to be 45. But that's the whole thing. That whole angle is 45 degrees. So we're going to take that 45 and we're going to split it in half. So we divide by 2, that's 22.5. So that means just on this side here, we get 22.5 degrees. So you could actually use a different angle. Now you want to check and say, really, is that correct? Well, let's go back to the previous problem because that was an octagon also. Take a look at the green triangle. The purple angle that we found, so this purple angle down here in the corner, was 67.5. Let's do a quick triangle sum. So 67.5 plus 90, and then subtract that from 180 using triangle sum. We get 22.5. So it just depends on what you would like to use. All right, so in order to do this, we are going to have to find, well, the area of a triangle is base times height divided by 2. All right, so we're going to need the apothem here, since that's our height. So let's go ahead and find that. It looks like that's going to be cosine. So cosine of our angle, 22.5, is equal to adjacent over hypotenuse, cross multiply. And then we can go ahead and type this in. So 9 cosine 22.5, that's going to give me 8.3149. And I'm going to put a little box around it because chances are I'm going to have to go back and use this again. So just make sure that you know where it is on your calculator. Okay, we also need to find the base of the triangle. So I'm going to call that length in purple B. All right, I don't want to use A to get it, so I'm going to use sine this time. So I have sine of 22.5, which is equal to opposite over hypotenuse, cross multiply. All right, looks like B is approximately 3.4441. And I'm going to use that one again also. So just make sure you keep track of where these are in your calculator on either your own personal calculator that you've been using or on the Desmos calculator they gave you through Schoology. Okay, now we need to find the area of the green triangle. So the area of the green triangle, well, let's see, it's half. Okay, the base of this thing, well, that's actually 2 B's put together. So I'm going to do 2B. So that's base times height. Well, height is the apothem. That's our A. Well, if you look, the 2's cancel. It's actually kind of nice. So really what we need to do is B times A. And it's going to be an approximation. So I'm going to do B times A using the stuff that is actually in my calculator. That's going to give me 28.6378. Okay, that's the area of the green triangle. So let's go ahead and put green box around that guy. Green box around that. All right, now we need to find the area of, well, the polygon is an octagon. So the area of the octagon. Okay, an octagon is 8. So that means that there are 8 of these green triangles. So that's going to give me approximately 229 0.1025, and I was given centimeters as units on this, so this is centimeters squared. Okay, there is our answer for the area of the octagon. Okay, one more. Now, we're given the apothem here, but I want to show you another way to do this. So this different method, I want to refer back to question number 2. So you know how I feel about convincing you that something actually works. So we'll go back to question number 2 here. And I want to take a look at the area of the octagon and really kind of write out some of the stuff that we did. Not a huge amount though, just a little bit. So I'm going to take, so just immediately underneath the yellow box, I'll go ahead and put it in like an orangish brown writing so you can see. It's kind of an addition to this. So I've got an 8, and then I'm going to replace the area of the triangle with what it actually was. So the area of the triangle was half times, in this case, base, which was 2b, times the height, which was a. Which, I mean, it makes sense. The half 2b times a gave us the area of the triangle, just in general terms. So it's half the base, so double the length on the bottom of the right triangle, times the height, which is the apothem, and then 8 came from however many triangles we had. So 8 came specifically from the fact that this was an octagon. Okay. So here's what I think we can do. Let's clean this up a little bit. So I want to keep the A. That's important. That's my apothem. And I am actually going to keep the half as well. So I want to try to see if I can blend the 8 and the 2b together. So let's see if we can do that. The 8 and the 2b. So thinking about an actual octagon. So nothing too fancy here. So there's my octagon. If I combine the 8 and the 2b, all right, let's see. This length was 2b, so's this length, so's this length, and this. So each of those lengths around the side of the octagon or the polygon itself represented the 2b. You'll see that I have 2, 4, 6, 8 of them. All right. So if I do 8 times 2b, I want to see what else that actually represents with regards to the picture. Okay, well, it looks like I'm going around the shape. So we know that that's shorthand for all the 2b's being added together. I want you to think about this. What is it that we're actually finding if we go all the way around a shape? And I believe this represents the perimeter. So I think if we pull the 8 and the 2b together, so 8 times 2b, this represents our perimeter. Which I'm going to call P. All right, I'm going to bring everybody else down with me now. So the 8 and the 2b got combined together. The half is going to come down. And then the A is going to come down as well. So I'll bring that down and the half. I think this is another way to find the area of our polygon. And that's what I would like to do on the next one. Okay, so still back to the green triangle. You still need to be able to do that though. So we're going to do green triangle. And I want you to think about how many of these green triangles you're actually going to have. Well, it depends on how many sides your polygon actually has. So if this is a hexagon, then we would have 6 of these triangles. All right, we have an apothem of 5. All right, so the red part's already given to us. We have to find the other angles. Now, at this point, it's ultimately up to you. I think I'm going to go back to finding the bottom right corner. All right, so I'm going to take the sum, which is, well, it's a hexagon, so 6 minus 2 times 180. Then I'm going to split it evenly to every corner. So I'll do 4 times 180 divided by 6. So that's going to give me 120. Then that 120 needs to be split in half, and that's going to give me 60. Oh, okay. I think we're looking at a special right triangle now. So this is 60. All right, I don't even need to do any trig at all. All right, let's take a look at this. So I know that opposite the 30 is, well, opposite the 60 is a root 3. All right, so a root 3 is equal to, in this case, it's 5. All right, let's go ahead and divide. Those simplify. I know that a is equal to 5 over root 3, but we wouldn't leave it like that. So let's rationalize. And I think we get 5 root 3 over 3. Okay, so that's going to be this here. All right, now I'm going to use my other way to find the area of this thing. I'm not even going to find the area of the triangle. Don't even have to do that. So the area of my hexagon is going to be half AP. So get half. Well, the apothem was given to me. That's 5. The perimeter, okay. To find the perimeter, we need to know the total length here. Well, all I'm going to do is double this guy. So it's 10 root 3 over 3. Okay, this is a hexagon, though. You have 6 of these. So I'm going to do 6 of those lengths. If I simplify, the 6 and the 3 will cancel. It gives me 20 root 3. Okay, that is my perimeter. Let's plug that in. Now from here, let's just finish the multiplication. So I think that's going to give us 50 root 3, and the unit was inches. This is inches squared. This is the area of our hexagon. So a couple of ways to do it. It's ultimately up to you. You'll still get the same answer. However, if the 30, 60, 90 triangle shows up or the 45, 45, 90 triangle shows up, the expectation is that you give the exact answer. So you use your knowledge of special right triangles. Otherwise, you use your knowledge of trigonometry.